Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to power systems engineering, basic concepts. So in this video, we are going to discuss about another very basic concept related to the basic concepts related to power, the power generation and transmission and load, which is polyphase circuits. So far, in the various discussions that we have done, the main point or the main concept, it always revolved around one voltage source and a single phase, okay, whether it is DC or particularly AC. When phase comes into play, we are talking about AC, okay, AC voltage. So it consisted of a single voltage source with a particular magnitude, frequency and phase, okay. This is single phase AC supply. So polyphase AC means, basically, if we break down this whole term, poly means many and phase means, polyphase means many phases, or it consists of many windings or conductors in the generator, AC generator or alternator, which produces multiple voltages of a particular magnitude and frequency, okay, magnitude and frequency, and different phase angle difference, okay, different phase differences with respect to each other. That is what polyphase means. So it consists of multiple windings, okay, each producing a particular voltage of same magnitude and frequency, but the displacement, the phase difference between each of these phases is different. That is what polyphase essentially means. So we are familiar with the discussion related to the representation of alternating voltage or alternating EMF, where a time varying EMF is represented as this, where this is the peak value or maximum value, sine or cos is used for representation, omega is the angular frequency, t is the instantaneous time, and phi is the phase difference. It can be leading and lagging, and same goes for current, and this is the waveform representation. So now the AC power system, it can be basically it can be broken down into three basic elements. There are a lot of things to it, but to simplify it, we can break it down into three main elements. First, the one which is responsible for generation of the power, the voltage, which is the AC form, which is AC generator or alternator. The one which is responsible for sending the power from one point to the other, which is the transmission system or transmission wires, and the one which is responsible for capturing the power, the point where it is sent, which deals with the collection of the power, that is the load. So it can be represented in this way. So here we have a voltage source, AC voltage source, consisting of a particular value, magnitude and phase. These are the transmission wires or conductors, the transmission lines, and then we have the load. So if we want to explain these things, first is the alternator. So it is an electrical generator which converts mechanical energy into electrical energy in the form of AC, alternating current. So as I said, mostly polyphase AC generators or alternators are used which has multiple windings, okay, multiple windings, each producing a particular voltage of certain magnitude and frequency, but the phase difference between them is different, okay, with respect to each other, that is different. They are displaced leading or lagging by particular phase angles. So same thing, equal magnitude and frequency but different phase angles. Then we have the transmission wires, or the transmission lines. They carry the electrical energy from one point to another, and their main characteristics is that they are capable of transmitting the electrical energy at very high voltages. Transmission at very high voltages has its own advantages, but that is a different topic of discussion which we'll do after this. So they operate at relatively high voltages, they transmit very large quantities of power over long distances, okay. So these are the main characteristics of transmission lines, and there are different types of transmission lines: overhead transmission lines, okay, then sub transmission lines and underground transmission lines. We'll discuss about them in detail. So these are the transmission lines. We'll also come across the color convention to denote each phase. Basically RYB system is used, where red, yellow and blue system, that is used for labeling the various windings in the particular point. Then we have the load. So the point where the power is transmitted is captured, it is collected, that is called as the electrical load. It consumes the electrical energy from one point to another and converts that energy into another form. Another important thing, depending upon the requirement at different stages of transmission, the voltages can either be increased or decreased with the help of transformers, step up and step down transformers. And also at certain points they can also be converted into DC, AC to DC, DC to AC using power electronics components. I have not included that here, otherwise it would have been very complicated. So remember, depending upon the requirement, power requirement, voltage requirement at different points during transmission and reception, voltages can be increased or decreased with the help of step up and step down transformers, or they can be converted into AC to DC and DC to AC. That interconversion also happens. So the load consumes the electrical energy and then transforms it, converts it into some other usable form depending upon requirement by stepping up, stepping down, AC to DC, DC to AC, that conversion. And depending upon again requirement, the load can be resistive in nature, inductive in nature or capacitive in nature. We have already discussed about resistive, inductive, capacitive circuits, their combinations, their AC analysis. You can check those videos. Okay, so now the different types of polyphase systems which are there. So first one is the single phase AC power system. So the single phase AC power system, it consists of one generator of a particular magnitude of voltage at a certain frequency and a single phase, then a pair of transmission wires or transmission line and a single load here. This is the simple single phase AC power system. It is also called as single phase two-wire system because there are two wires here, okay, one is this and one is this. Single phase because a single voltage source of one phase, particular phase angle, and one load depending upon requirement, resistive, inductive or capacitive. Then we have a single phase three-wire system. So this is which we discussed, it is a single phase two-wire system. This one is a single phase three-wire system. Here the difference is this neutral line, everything else is the same, there is a neutral line which is there. So here we have two voltage sources, okay, two voltage sources of equal magnitude, frequency and phase angle. The phase angle is the same, but two voltage sources are used. We have two loads, resistive, inductive or capacitive depending upon requirement. We have a pair of transmission lines, each connecting one end of the voltage sources, either voltage sources, to the loads, and another line which is taken from the common point from the voltage side to the load side. This is called as the neutral line. Okay, this is called as the neutral line. These are the two pairs of transmission lines, and this is the neutral line. We'll discuss how neutral line comes into play. For now, just understand this is called as the neutral line. Then we have a two-phase, three-wire system. Same thing as the before, the construction is the same, but here the two voltage sources that are used, they have the same magnitude and frequency but different phase angle. Usually there is a phase difference of 90 degree with respect to each other. That is the common system. So same thing, two voltage sources, equal magnitude and frequency but different phase angle, two pair of transmission line, each connecting one end of either voltage source, connecting it to the load, and then one wire which is taken from the common point from the voltage side to the common point on the load side. This is called as the neutral line. So here this is the two-phase, three-wire system consisting of two voltage sources, same magnitude, frequency, different phase, with a phase difference of commonly 90 degree with respect to each other, two loads, three wires, two transmission wires, one neutral wire. Next is the three-phase, four-wire system. So here we have three voltage sources of equal magnitude and frequency but three different phase angle. Usually there is a difference of 120 degree with respect to each other, leading and lagging. We have three loads, then we have three wires, each connecting one of the voltage source to the respective loads, and here we have a neutral line. Okay, one neutral line, three wires for each of the three voltage sources and a neutral line, this one. So here this three-phase system is most commonly used in AC power systems for transmission, distribution, everything. The three-phase, four-wire system, depending upon the design, this neutral wire can either be present or absent, because there are two types of connection of phases, the star and delta. Depending upon that, this neutral wire can either be there or not. So it is either three-phase, three-wire system or three-phase, four-wire system, but the three-phase is always present. So this is the most commonly used transmission system, transmission and distribution system, generation, transmission and distribution system. So this is the waveform, this is the phase 1, this is for the this two-phase system, 0 degree and 90 degree phase difference, and this is the three-phase system, single phase, two-phase and three-phase. This three-phase system is most commonly used in AC power systems. Okay, this is the most commonly used. So whenever we'll have any discussion, it will be with respect to this. So here there are the three-phase voltages, each of them displaced by 120 degree, leading or lagging. So this is the whole thing, and this is the representation of the three voltages with respect to the sign. This is the same maximum voltages, same frequency but different phase angle. Okay, this. Then as I said, the phase sequence, okay, the labeling of the different voltages, the order in which the voltages in the three phase or windings or coils starting from the alternator they reach their maximum values, the peak values, that is called as the phase sequence. So here for this 3-phase sequence, the labeling of the 3-phase voltages, it is a usual practice to name them after the 3-phase windings as red, yellow and blue. Okay, RYB system. Okay, so most commonly you will find this. Other kinds of labeling are also there where it is labeled as ABC, 1, 2, 3, but most commonly you will find RYB system, where R is for red, Y is for yellow, blue, B is for blue. But other naming conventions are also used. It is specified in different books. Different conventions are used, A, B, C, 1, 2, 3, whatever, but it is specified. So this is some of the basic concepts related to polyphase circuits. Okay, so we discussed that, but most commonly used system is the 3-phase 4-wire or 3-phase 3-wire system. Okay, the most commonly used system.